This video is going to cover Chapter 1, Section 6b. In this section, we are going to be solving radical equations and other types of equations like a cube root or a fourth root, and we'll also be solving equations that are raised to a rational exponent. So let's go ahead and see what the steps are for solving a square root equation. So step number 1 is to isolate the square root. Step number 2, we'll square both sides of the equation. By squaring both sides, that will eliminate the radical. And then we need to solve the remaining. Then we must check all answers, because whenever you solve an equation by squaring it or raising it to a rational exponent, that can cause extraneous solutions. So we must check all of our answers to make sure that they're not extraneous. So let's try some examples. So here's my first example, number 1. Step number 1, isolate the radical. So I need to move the square root and leave it either on the left or the right side. So I'm going to go ahead and add the square root of 15 minus 2x to the right side. It's gone from the left, and now I have it isolated. So now I have x equals 15 minus 2x, and that's still under the square root. The next step is to square both sides. So I square the right side and square the left. Remember, when you square that radical, it's going to disappear. So now I'm left with x squared equals 15 minus 2x. So next we need to solve. We need to set our equation equal to 0. So I need to move the 2x to the other side and the 15. So x squared plus 2x equals 15. Move the 15. X squared plus 2x minus 15 equals 0. I now have a quadratic equation that I can solve. I can solve it with factoring, quadratic formula, or completing the square. So I'm going to go ahead and move this to the top just so I have some more room. I'm going to go ahead, this is factorable. For me, if I can factor something, factoring is the fastest way. So x squared plus 2x minus 15. Factors of negative 15 that give me positive 2. X plus 5, x minus 3. I need to set each of the factors equal to 0 to find the value of x. Subtract 5. My first solution, possible solution, is x equals negative 5. Add the 3, x equals 3. So remember, anytime you square an equation to solve it, we need to check for extraneous solutions. So now what I need to do is take my original equation, the x minus the square root of 15 minus 2x. I need to replace x, both of them, with first negative 5, and then I'll do the exact same thing again, let me write it again, with the positive 3. Now, keep in mind that you need to check everything. Okay, just because maybe you get the first one to fail doesn't automatically mean the second one will work, or just because you get the first one to work doesn't mean the second one won't. You can have 2 things working, only one, so you do have to check everything. So let me go ahead and plug it in. Negative 5, 15 minus 2 times negative 5. That's still under the radical. Negative 5 minus 15 plus 10 equals 0. Negative 5 minus 15 plus 10 is 25. Square root of 25 is 5. Negative 5 minus 5 is negative 10, which does not equal 0. So that just told me that solution does not work. So it's out of there. It's extraneous. Now I need to double check the 3. So again, I've already set up my equation. Let me go ahead and just plug in the positive 3. So 3 minus 15 minus 2 times 3. and that's still under the square root. So 3 minus 15 minus 6. 3 minus the square root of 9. Square root of 9 is 3. 3 minus 3 is 0. This one works. So x equals 3. That is the solution for this radical equation. Let's try number 2. The process is going to be the same. So again, step number 1, isolate the radical. So I'm going to go ahead and add 3x plus 18, that square root, to the other side. Now I have x equals 3x plus 18 under the square root. Again, next step, square both sides. Remember, when you square the radical is going to disappear. So then the only thing that's left here is the 3x plus 18. I now need to get it in standard form to see if I can factor it, because again, factoring for me is the fastest way. Again, you could also do quadratic formula or completing the square, whatever you want to do to solve to get your values of x. So now I have x squared minus 3x minus 18. I'm looking for the factors of negative 18 that when I combine them give me negative 3. And that's going to be x minus 6 and x plus 3. Set each of these factors equal to 0. So x minus 6 equals 0. Once I solve this by adding 6, I get x equals 6. I need to do the same thing to the x plus 3, set it equal to 0, and my other solution is x equals negative 3. Again, remember, we're not done yet. We need to check them. So I'll go ahead and write down my original equation twice. So I can get it set up, ready to plug in. So the first one I'm going to check is the positive 6. So each place that I see x, I'm putting in positive 6. I get 18 plus 18. 18 plus 18 is 36. Square root of 36 is 6. 6 minus 6 is 0. So that one works. So x equals 6 is a good answer. Let's check the negative 3. So again, I am going to plug in negative 3 for my x's. Negative 3 minus the square root, negative 3 times positive 3 is negative 9. Plus 18, negative 3 minus negative 9 plus 18 is 9. Negative 3 minus 3, this gives me negative 6, which does not equal 0. So this solution is extraneous. So the only solution here is x equals 6. Let's try number 3. This one's a little different. So again, step number 1, isolate the radical. Notice this time it is already isolated for us, so now I'm just going to square both sides. Squaring the radical makes the radical disappear. Now, on this one, I can't just distribute that exponent. I actually have to FOIL it. So really what I'm doing here is 2x minus 1 times 2x minus 1. Once I FOIL this, I get 4x squared minus 4x plus 1. So what you can do here is either memorize the pattern for a binomial squared or actually write it 2 times and do first, outer, inner, and last. So next I need to get my equation set equal to 0. So I'm going to subtract 4x from both sides. If you'd rather move the 13 first, you can also do that. Now I like to keep my x squared term positive, so this is why I'm moving the terms to the other side. So now I have 0 equals 4x squared minus 8x minus 12. Now I need to either factor this, use some kind of method for solving this. Always, I'm going to try to factor first. It's the fastest. I can look at this trinomial and see that I can factor out a GCF of 4 before I begin doing the factoring of the trinomial. So I'm going to divide everything by 4, and I'm left with x squared minus 2x minus 3, and then I'm going to move the equal 0 to the right. Now I can factor the trinomial, and that's going to become factors of negative 3 that give me negative 2, x minus 3, x plus 1. I need to set each of my factors equal to 0. Now, if this GCF would have had a variable with it, I would have gotten a solution. But when it's just a constant, you really don't even need to do it because that's nonsense. Then I do x minus 3 equals 0, x plus 1 equals 0. Add 3, x equals 3, subtract 1, x equals negative 1. Again, we must check. So now I'm going to take my original equation, the 4x plus 13, which is under the square root, and 2x minus 1. Let me go ahead and set it up 2 times because I have 2 solutions to check. I'm going to first plug in the 3. (12 plus 13). 2 times 3 is 6. 12 plus 13 is 25. Square root of 25 is 5. This one checks out, so x equals 3 is a good answer. Let me try the negative 1. So 4 times negative 1 plus 13. 2 times negative 1 minus 1. Negative 4 plus 13 gives me 9. Square root of 9 is 3. Let me finish up this side. Negative 2 minus 1 is negative 3. 3 does not equal negative 3, so this solution is extraneous. So again, I only have one solution here. Number 4, let's go ahead and work on isolating our radical. So first thing I need to do is move the 1 to the other side by adding it to get it away from the radical. So now I have the square root of 6x plus 7 is equal to x plus 2. Next step is to square both sides. Again, from on the left side, squaring this square root makes it disappear. Again, I need to square this binomial, so again it turns into a trinomial. Again, if it's better for you to write x plus 2 times x plus 2 and then FOIL it, you can do that, or memorize the binomial squared pattern. So once I square that x plus 2, I get x squared plus 4x plus 4. Again, I need to get my like terms together, so I'm going to subtract 6x. 7 equals x squared minus 2x plus 4. Move the 7. 0 equals x squared minus 2x minus 3. I actually have the exact same trinomial that I just factored on number 3. So again, this factors into x minus 3, x plus 1. Again, set each of the factors equal to 0. Solve for x by adding 3, subtracting 1, and now I need to check. So again, let me rewrite the problem twice. So there's the first time. Let me write it again. Just get it set up. This is still under the radical. Okay, so for the first check, I'm plugging in the 3. going to multiply. Over here I can add the 3 plus 1. 18 plus 7 is 25. Square root of 25 is 5. 5 minus 1 is 4. So 4 equals 4. X equals 3 is a good answer. Let me try the negative 1. 6 times negative 1 plus 7 minus 1 equals negative 1 plus 1. Negative 6 plus 7 minus 1. Negative 1 plus 1 is 0. Negative 6 plus 7 is 1. The square root of 1 is 1. 1 minus 1 is 0. 0 equals 0. We actually now have two solutions here. So again, as you saw, just because the first one works doesn't mean the second one is automatically not a solution. So you must check everything. All right, the next 4 examples are a little complicated. We're actually going to do this squaring process twice because we're going to have 2 radicals that we need to eliminate. So let's try number 5. So again, remember step number 1 is to isolate the radical. Now I actually have 2 radicals here, but again, I always like to try to keep the radicals positive, so I'm going to add this one. So the one I'm working on isolating is the 2x plus 3. So 2x plus 3 is equal to 1 plus x plus 1 under the radical. Next step, square both sides. So for the left side, squaring that makes this come out. However, the right side is more complicated. So what I need to do here, again, remember this is a binomial squared, so it's 1 plus x plus 1 times 1 plus x plus 1. So just to show you how to do this one, because this one's a little bit more tricky, I'm going to go ahead and do the whole FOIL for you. So first gives me 1 times 1. Outside gives me 1 times x plus 1 under the radical. Inside the same thing. Now you don't need to show that 1 on the outside, but it's going to help me when I go to add those middle terms. So this was the first. This was outside, and it was this one. This is inside, and it's this one. And now I'm going to do last. Remember, whenever you multiply a radical by itself, the radical disappears. So now I'm just left with x plus 1. Now I need to go back and add like terms. So these two here in the middle, 1 plus 1 is 2 times x plus 1 under the radical. I also have like terms here, a 1 plus 1, so this gives me 2, but then nothing to add to this x, so it's just plus x. So that's what the right side simplifies to. Now notice I still have a radical in my equation. Again, I need to start all over again from step 1 again. Step 1, isolate the radical. So let me move the 2 away from it. 2x plus 1 equals 2 times the square root of x plus 1 plus x. Move the x. X plus 1 equals 2 times x plus 1 under the radical. Now that the radical is isolated, now I square both sides. So over on the left side, again, it's a binomial squared. It is going to turn into x squared plus 2x plus 1. The right side, this exponent of 2 needs to go to the 2, square that, but then when you square the radical, it just disappears. Now the reason why I can just distribute that exponent is there was no plus or minus sign in between here. Whereas on this side, see how it had a plus sign, so this is why you had to FOIL that one. So So the next thing I need to do is start to try to combine my like terms. I'm going to go ahead and distribute the 4. Let me rewrite the left side. And now I need to start grouping my like terms. So I'm going to move the 4x first. X squared minus 2x plus 1 equals 4. Next I need to move the 4. X squared minus 2x minus 3 equals 0. And again, that same trinomial. This is just a coincidence. So x minus 3, x plus 1 equals 0. Set each one equal to 0. Solve for x. X equals 3. And x equals -1. Again, we must check. So let me go ahead and rewrite my two equations. So 2x plus 3 minus x plus 1 equals 1. I'll just go ahead and do them one at a time. So this is, I'm going to plug in 3. 3 plus 1. 6 plus 3. 3 plus 1 is 4. 6 plus 3 is 9. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1. 1 equals 1. This is a good solution. Now let's do the exact same thing and check the -1. So again, let's plug it in. So 2 times -1 plus 3 minus -1 plus 1 under the square root. And this is under square root. So -2 plus 3. -1 plus 1 is 0. -2 plus 3 is 1. This just gives me a 0. Square root of 1 is 1. 1 minus 0 is 1. This one also checks out. So the two solutions are x equals 3 and x equals -1. Number 6, same idea here. We're going to first isolate, square, and then we'll have to repeat the process again because we do have two radicals here. So first thing I'm going to do is move the x minus 3, that square root, to the other side by adding it. Two minus 2x minus 5 equals 1 plus the square root of x minus 3. Again, next step, square both sides. So the left side, the 2x minus 5, just comes out of the radical. Again, remember on that right side, we need to FOIL that thing. After we FOIL it, we're going to end up with 1 plus 2 times x minus 3 under the square root plus x minus 3. I now need to isolate the radical again, but let me go ahead and combine these two like terms here first. So now I have 2x minus 5 equals -2 plus 2 square root x minus 3 plus x. Move the 2. 2x minus 3 equals 2 times the square root of x minus 3. Move the x now. X minus 3 equals 2 times the square root of x minus 3. And now the radical is isolated. Square both sides. This is going to end up being x squared minus 6x plus 9. Over here, no plus or minus sign, so square the 2, and then the radical disappears. I need to distribute the 4. And now I need to move like terms together. So subtract the 4x. x squared minus 10x plus 9 equals negative 12. I need to move the 12, so I'm going to add it. X squared minus 10x plus 21 equals 0. I now need to factor this, and this one's actually different now. Factors of 21 that give me negative 10. That's going to be x minus 3 and x minus 7, because I need a positive 21. Set each of the factors equal to 0. Add 3. X equals 3. Add 7. X equals 7. I now need to do the check. So again, let me rewrite my original problem to x minus 5 minus x minus 3 equals 1. So plug in 3. So 2 times 3 minus 5, 3 minus 3. These are all under radicals. So 6 minus 5. Here 3 minus 3 is 0. This becomes a 1. This becomes a 0. Square root of 1 is 1. 1 minus 0 is 1. That one checks. This is a good answer. Do the same thing, plug in the 7 now. So I'll do 2 times 7 minus 5. 7 minus 3 equals 1. 14 minus 5. 7 minus 3 is 4. Square root of 9. Square root of 4. This becomes 3 minus 2. 3 minus 2 is 1. 1 equals 1. This one also checks. So my advice to you is when you're taking this quiz on Friday, if you feel you're running out of time, at least get it solved. You'll probably lose minimal points for forgetting to go back and check. At least get them solved. Let's go ahead and try number 7. So again, work on isolating the radical. Now notice the right side is already isolated, so right here at this point I could go ahead and square this. I could move the 2 over and then try to isolate the x plus 5, but I'll go ahead and work with it how it's given. So again, you need to FOIL this left side. So this is going to become x plus 5 minus 4 times x plus 5 plus 4. And then over here, it just comes out of the radical. So now I'm going to combine like terms so I can add this 5 and this 4. So x plus 9 minus 4 times the square root of x plus 5. Now I need to work on isolating that radical there. So what I'm going to do is, I don't want a negative radical, so let me go ahead and move it over. So x plus 9 equals x minus 1 plus 4 times x plus 5. I'm going to move the x. 9 equals negative 1 plus 4 times x plus 5. Add the 1. So now I have 10 equals 4 times the square root of x plus 5. I need to square both sides. This becomes 100. I'm squaring the 4, becomes 16, and then when I square the radical, it just disappears. I need to distribute the 16. 16x plus 80. Need to move the 80. (20) equals 16x. Divide by 16. And x equals, I can divide them both by 4, 5 over 4. Let's go ahead and check it. So my original equation, x plus 5, that's under the radical, x minus 1. 5 over 4 plus 5 minus 2 equals 5 over 4 minus 1. Need to find a common denominator. It's going to be a 4. So 5 over 4 times this by 4. Over here I'll change the 1 into 4 over 4. So now over here I get 25 over 4 minus 2. 5 over 4 minus 4 over 4 is 1/4. I can square root these. This becomes square root of 25 is 5, square root of 4 is 2. Square root of 1 is 1, square root of 4 is 2. And then now I need to subtract this. I can find a common denominator. Make this 4 over 2. And now 5 minus 4 is 1. 1/2 equals 1/2. It checks. So this is a good solution. Let's try number 8. Same thing, it's already isolated for me, so let me go ahead and just square both sides. Again, I need to FOIL that right side. So 4x plus 1 comes out. When I FOIL the right side, I'm left with x minus 1 plus 4 times the square root of x minus 1 plus 4. I can combine like terms here, and I get x plus 3 plus 4 times the square root of x minus 1. I need to isolate my radical, so I'm going to subtract x. 3x plus 1 equals 3 plus 4 times square root of x minus 1. Move the 3. 3x minus 2 equals 4 times the square root of x minus 1. My radical is isolated, so now I square both sides. So again, I need to do the binomial squared pattern or FOIL it. 9x squared minus 12x plus 4. Square the 4. Squaring that radical makes it disappear. I need to distribute the 16. I now need to move the 16. I can move either the 16x first or the 16. Combine the like terms. Now move the negative 16 by adding it. So now I have 9x squared minus 28x plus 20 equals 0. First thing I would do is look to see if there's a greatest common factor. There is not. So now I am going to factor this trinomial. So my factor's a 9. I'm going to do 9 and 1. My factor's a 20. I'm going to do 10 and 2. Now, once you're putting these factors in, remember, you need to FOIL this. Definitely check the outer and the inner to see if you get the negative 28. So this gives me negative 10. This gives me negative 18. When I add them, I do get the negative 28. Obviously, if you've done the factors of 9 and 20, those are already okay. So let me go ahead and get rid of this. And now we'll set each of the factors equal to 0. 9x minus 10, x minus 2 equals. Add 10. 9x equals 10. Divide by 9. and x equals 10 over 9. Add the 2, and x equals positive 2. We need to check, so we plug them in. So take your original equation, 4x plus 1 equals x minus 1 under the radical plus 2. I'm going to first check the 10 over 9. Multiply 40 over 9. I'm going to make the whole number 1, 9 over 9. Same thing here. Make this 9 over 9. 49 over 9. This becomes 1 over 9. Square root individually, you get 7 over 3. Over here, square root the 1, square root the 9. Common denominator, it's going to be a 3. Make this 6 over 3. And then notice 7/3 equals 7/3. It checks. This is a good answer. Now I'm going to do the same thing, and I'm going to plug in the 2. So 4 times 2 plus 1 equals, smaller, equals 2 minus 1 plus 2, and that's under the radical. So 8 plus 1, 2 minus 1, 9, square root of 1 is 1, square root of 9 is 3, 1 plus 2 is 3. This answer also works. So we have 2 solutions for this one. So again, remember that check is mandatory. Okay, so that's it on the square root part. Now let's try some other roots. So again, if it's any other root other than a square, you're just going to change it to the same power as the index. Also, if the expression is raised to a fractional exponent, we're just going to raise it to its reciprocal. So the next one is a cubed root. So this little 3 is what I referred to as the index. So in order to solve this, again, process is the same. We need to isolate the radical. So I'm going to add the square root of x to both sides. I'm sorry, the cubed root of x. So 4x squared minus 4x plus 1 equals the cubed root of x. Now to get rid of that radical, I am going to raise both sides to a power that's equal to the index, which is 3. That causes the radical to disappear. And now I solve what remains. All I need to do is subtract the x. 4x squared minus 5x plus 1 equals 0. I need to factor the trinomial. It'll actually factor into 4x minus 1 and x minus 1. Set each of the factors equal to 0. Add 1. 4x equals 1. Divide by 4. And x equals 1/4. Over here, I'll add 1. And x equals positive 1. Again, we need to check it. So we're going to 4x squared minus 4x plus 1 minus this. And again, these are cube roots. So let's plug in the 1/4. So 4 times 1/4 squared minus 4 times 1/4. And then the cubed root of 1/4. Now, don't worry that you're like, oh, how am I going to do a cube root of 1/4? Watch what happens when I simplify what's under that first radical. 1/4 squared is 1/16, so this will give me 1/4. -4 times 1/4 is just -1 plus 1. So I'm just going to leave this under the radical. It's okay. And now here, notice underneath here, -1 plus 1 is gone. So now I'm just left with the cube root of 1/4 minus the cube root of 1/4. Anything subtracted from itself is 0, so this answer works. I'm going to do exactly the same equation, but now I'm going to plug in a 1. Let's see. Let me go ahead and see if I can move this. I'll just do it right above. So 4 times 1 squared minus 4 times 1 plus 1 minus 1, and this is a cube root, and this is a cube root. So 4 minus 4 plus 1 minus the cube root of 1 is 1. This is a cube root also. This becomes 0. So the cube root of 1 minus 1, cube root of 1 is 1. 1 minus 1 is 0. This answer also checks. Now we have an equation where we have something raised to a fraction exponent. So again, remember on these, we're going to isolate and then we're going to raise it to the power that's the reciprocal. Let me go ahead and add 4x plus 2 raised to the 1/3 power to both sides. 3x plus 7 to the 1/3 power equals 4x plus 2 to the 1/3 power. I'm going to raise both sides to the reciprocal power. So the reciprocal of 1/3 is 3. Remember, whenever you multiply a fraction by its reciprocal, the answer is 1. So this just becomes 1s. So now I'm just left with 3x plus 7 equals 4x plus 2. Nice linear equation here. So go ahead, we're just solving for a single variable. -1x plus 7 equals 2. Move the 7. -1x equals -5. Divide by -1, and x equals +5. So let's go ahead and check it. So 3 times 5 plus 7. Now again, remember, we could also think of this as a cubed root, if that helps you. Because the 1/3 power, remember that denominator is a root. And then minus 4 times 5 plus 2. Again, if you want to leave it as a cubed root, or you can leave it as the exponent. So 15 plus 7 minus 20 plus 2. These are cube roots. So I get 22. Cube root of 22 minus the cube root of 22. Again, anything subtracted by itself is 0. So this is a good answer. Let's try another example. This is the 4th root. Same process here. Again, remember, when we want to isolate the radical first, and then what we'll do is raise both sides to a power that's equal to the index. The index is 4, so I'm going to raise both sides to the 4th power. This one cancels. I actually have to figure out what 2 times 2 times 2 times 2 is, and that's 16. Move the 16 to the other side. Factor it. Solve it by setting it equal to 0. Subtract 8. Add 2. And now I have to check. So again, take your original. X squared plus 6x equals 2, and this is the 4th root. So let's try the -8 first. I get 64 minus 48. 64 minus 48 is 16. Now remember, this is a fourth root, not a square root. So 2 times 2 times 2 times 2. So the fourth root of 16 is 2. 2 equals 2, it checks. This is a good answer. Let's try the 2. So 2 squared plus 6 times 2. Fourth root. So 4 plus 12. Again, I get 16. And we just saw that the fourth root of 16 was 2. So this one also checks. So 2 solutions here. 12 is similar because, again, remember, the 1/4 power is the same thing as the fourth root. So again, what we'll do to get rid of this 1/4 is raise both sides to its reciprocal. So this will come out. This becomes a 1. So 3x squared plus 52x. 4 to the 4th power is 256. Move it over. 3x squared plus 52x minus 256 equals 0. I now need to factor this trinomial. There isn't a GCF, so let me go ahead and I'll guess and test with the factors of 3. 3 times 1. Now the tricky part is the factors of the 256, and that's going to be 64 times negative 4. Set each of the factors equal to 0. Subtract 64. 3x equals 64, negative 64. Divide by 3. And my first solution is negative 64 over 3. Over here, add 4. X equals positive 4. I now need to check this. So 3 times negative 64 divided by 3 squared plus 52 times negative 64 over 3 equals 4. So let's go ahead and square that 64 over 3. So when I square it, let's see what we get. 64 times 64 gives me 4,096. These 3's will, well, no, let's not cancel it yet. Let's do 3, and then this becomes 4,096 over 9. And then 52 times 64, because I can't simplify that diagonally. So 52 times 64 gives me, well, let's just make this a negative. Let's make this negative 3328 over 3. I can simplify this, make this 3. So now I have common denominators here. So now I can subtract 4,096 minus the 3,328. I get 768 over 3. And again, this was raised to the 1/4 power. All of this was under the 1/4 power. So if I divide 768 by 3, I get 256 to the 1/4 power. And then if I raise 256 to the 1/4 power, which is really just finding the fourth root, I get 4. 4 equals 4. That first solution checks. So this is good. Need to do the same thing with the positive 4. So 3 times 4 squared plus 52 times 4 equals 4. And again, remember, this is all raised to the 1/4 power. So 3 times 16 plus 52 times 4 is 208. still to the 1/4. 16 times 3 is 48, plus 208 is 256. 256 to the 1/4 power is 4, so 4 equals 4. This one also checks. 2 more examples and then we're done. I know this is a long video. All right, so again, we have fraction exponents. We want to get rid of it. So what I'm going to do is multiply by the reciprocal. So I'm going to multiply it by 5. So this becomes x minus 3 squared. This one just becomes 4x. I need to FOIL this binomial squared. So x squared minus 6x plus 9. Move the 4x over. X squared minus 10x plus 9 equals 0. Factors of 9 that give me negative 10. That's going to be negative 1, negative 9. Set each of the factors equal to 0. Add 1. First answer is x equals positive 1. Second answer is x equals positive 9. I now need to plug it back in to do the check. So 1 minus 3 raised to the 2/5 power equals 4 times 1 to the 1/5 power. So negative 2 to the 2/5 and 4 to the 1/5. So this is like finding the 5th root of 4. Over here what I can do is do negative 2. Let's see. Same thing. I could do the exponent first. I could square the negative 2 and it becomes 4. And then now it's to the 1/5 power, which is the same thing as what I just wrote. Actually, I didn't even need to make that a root. Let's go ahead and put it back as 1/5. So 4 to the 1/5 equals 4 to the 1/5. This is a good answer. So obviously I can't find the 5th root of 4 without a calculator. So just showing that the two sides are equal is enough. And then here, 9 minus 3 to the 2/5. 4 times 9 to the 1/5. 6 to the 2/5. Over here will be 36 to the 1/5. And then here I can square the 6. And then what's left is 1/5, which is the same thing I had. So this is also a good solution. Last example. So again, I want to get rid of the fraction exponent. So I'm going to raise both sides to the 4th power. That'll cancel that. Now, this 4 will also go to the 3. So 3 to the 4th power is 81 x cubed. And then here it becomes x squared. Set it equal to 0. 81 x cubed minus x squared equals 0. Factor GCF out of x squared. Set each of the factors equal to 0. X equals 0. And then 81x equals 1. Divide by 81. And the other solution is x equals 1 over 81. Again, we have to check it. So when I plug in 0, 0 raised to the 3/4 is just 0. And then here, 0 to the 1/2. 0 equals 0. That one works. Let's plug in the 1/8. 1 over 81, sorry. So 1 over 81 raised to the 3/4 power. 1 over 81 raised to the 1/2 power. So again here I could do the 4th root of 81 and get 1 over 3. I could cube that, get 3 times 1 over 27. That'll simplify to 1/9. And here I can, 1/2 is really like the square root. So then this gives me 1/9. 1/9 equals 1/9. So this is also a good solution. So they both work. They're both good solutions. So that is it. You have the 1-6B homework on WebAssign, and you do have a quiz on this on Friday. So that's it.